Hello, everyone. Welcome to this workshop. Let's wait for a few minutes for others to join, and we will have the chat available on YouTube, and also in the description of this video, there's a Google Meet link which you can join if you want to have your audio in this workshop, or you want to share something which we are troubleshooting. As we begin and as we are waiting for others, you can check our website, sharelearn.com. So shrlrn.com, where you'll find the information for all the labs we have and our Facebook group and LinkedIn group. We also have our Slack channel and Telegram group over there. To see the labs which we'll be doing today, go to the practice section and click on Docker Labs. We have basic labs over there, and we're working on adding more labs. Just to give you a brief idea of what the containers are a lean virtual machine, you can say, without an operating system. So it all started when we have computers in the racks and in the data center, and for every new requirement, we have to get a new computer, set it up with an operating system, and install applications on it. But slowly we moved to virtualization, where we install the servers and then create a virtual machine on the top of it. Each virtual machine which will have its own operating system, which was redundant and taking up resources. Also complex in management of the patches. So the latest technology which we are looking at as containers, where if we remove the requirement of operating system and still achieve the isolation in the network and the storage space. So a container will have its own IP address and storage space, but it'll rely on the host for the operating system. Let's look and jump into the Docker and see how we can look into the labs. So in the previous workshop, we worked through these labs, and we will skip through the first few labs as we have already done them in the previous workshop. And description has the link for that video as well. So we were able to cover the first 101 lab and interacting with Docker container. And this time we'll be going through Docker Lab 103. So in order to use these labs free, and these labs are free of cost, you have to register and create an account on hub.docker.com. So if you go there, just click on choose a Docker ID and a password there. It'll send you a link, and once you confirm, you'll be good to go. Coming back to Docker Lab 103, on step 1, open the Play with Docker, log in with your Docker Hub account, click on Start. This will start a 4-hour session Click on Add New Instance. And let's create a container and get into the bash prompt. So we discussed earlier in previous workshop that you can go into the container with the IT option. I is for the interactive session and T is for the terminal. So we'll be using terminal for input and output. In here, as the image which we're going to work on wasn't available locally, Docker has pulled it from the Docker Hub and confirmed that it has downloaded the image. Now we are inside the container. Let's do an update. As this is Ubuntu, we're going to do apt-get update. Let's install a program called Figlet. And run it to say, hello, Docker. At this time, you can exit the container with the exit command. You're back into the server host. If you list the containers now, you'll see that our container has exited as we have not given any command to run it continuously. We can check the difference between the original Ubuntu image and the changes we have made on our own container. As in this case, these are simple steps of apt-get update and installing Figlet. This could be complex and depends on your use case, but in this case, we are just checking what are the differences between the base image we use of Ubuntu and the changes we have made. So if you do a diff and an ID, you don't have to define the complete ID. You just have to, all the containers available, you should have to remove the ambiguity around it. So in this case, as we have only one container, we can say one, and that'll tell the system which container we are talking about. And it tells us that all these files have been changed since the base image have been used. These are the apt-get update and the Figlet installation. Now we can commit the changes and create a new image out of it. So now if we check the images, it'll show us a new image which has no name or tag on it, but the changes have been captured. So let's tag our image. And in this case, we'll just use number 9 as that will remove ambiguity and tell the system which image we're talking about. And name it as first image. If you go back to image ls, we'll see that the repository has been named first image and tag is latest, which is by default, as we have not given any tag for this image. Now we can run a new container with the new image, and we'll see that it's not the base Ubuntu image, it is with the changes we have made. As if I do this with the Ubuntu image, I will not get the results. By default, Figlet is not installed on the Ubuntu. This is just to give you a base idea. These could be any changes you make. You could install some own binary code or install an application and build a new container image out of it. And that's pretty much for this lab. Let's go to the next one. Any questions so far? Sounds good. Now, next, we're going to create an image from our Docker file. So we do vi Docker file, And in here, we'll just copy these for now. So we're doing the same thing. In this case, we're saying our base image will be Ubuntu. So from Ubuntu, we're running a command called apt-get update and another command of apt-get install figlet. Next, we're saying, as long as this container is running, run the command figlet hello, which will be one time as it's not a continuous command. Let's do escape and :wq to save the file. Okay, doesn't let me do that. Okay, so we are out of the Docker file, and in order to build an image from the Docker file, we have to use the command docker image build. We have to give the tag with the -t and image name with the tag. So in this case, we're using 0.1 as the tag. And you have to give the location of the Docker file as this is in the current directory. We're just using a dot operator. Let's see our new image. And this is the image we have. Image from file, tag 0.1. Let's check by running that. And this time we get the same output as this is what we're trying to do in the Docker file. You can also check that with the image history that what all changes have been made on that particular image. So in order to remove ambiguity and select my image, I'll just pick the first number, which is 2, and I get all the details of the changes which have been made into this image. Especially the ones which were recently made are very clear that I have taken the base image, added apt-get update, app install figlet, and a command over there for the figlet hello docker. Now, these changes in a production environment when you're using Docker will be much more complex than just 3 steps. And Docker image history will definitely help you looking into the details of how the Docker image has been built. Let's go to the Docker file and change the line for the command to be, instead of hello Docker, to, so here we're going to say hello Docker 0.2. These changes could be anything you want. In case escape is not working, just use Control-C in this environment. Now, with the new Docker file, let's build a new image. And all we're changing in this image is the tag to be 0.2. So our image is still image. Our image name is image from file, and our tag is 0.2. Let's run a container. There you go. And if you look at the image history, give me a second, let's check our new image. So if you want to check history on this one, you'll see that the changes have been captured over here. And that is our lab 104. Any questions on that? Any questions on Docker? Okay. Let's use a container with a service that we can expose to the outside, like an Nginx server. So in this case, the way it works is we call out, use the dash p option and tell that we're going to use 8080 colon 80 for Nginx. And in this lab environment, once this is set up, you're going to see a new port over here. So as we have mentioned, 8080, this is the external port and 80 is the container port. If you click on it, you will see this as being offered by the container. So this page is coming from all the way from the container we just built. And in this, as we're not using the daemon mode, it'll gonna stop the moment we do Control C. If we do docker ps-a, we're gonna see our container has exited because we have done Control C on that. And this was a container and specific, the Nginx image was used. Now, you could definitely restart your container by just using a command docker start and give a unique identifier for that. In this case, we just have 5 containers here, and B is good enough to resolve the ambiguity from other containers. Now, if you do docker ps-a, you'll see that this container is running, and if you refresh your page, you'll still see the Nginx page coming from. Important thing to remember here is that first port which you give is for the host. So that's the port you will be accessing. And the second port which you give is for the container itself. So that port is what container is exposing. You can stop the container with the docker stop command and ID of the container. You don't have to define the entire ID. You can just say um, you have to define the number of alphanumeric letters where the ambiguity will be resolved among the containers available on that machine. Let's rerun the container, and this time we're using name option to name our app, our container as app1. We're using -d to say it'll run in the daemon mode, so we don't have to see the logs flowing and we don't have to be active on that server. If we do docker ps-a now, we're going to see our new container is already there and it's running. Usually, if you have 2 containers running on the same port, you're going to have a problem. But as only one of them is running right now, that is not an issue. So if you refresh it, this time it's coming from the new container. Now, as we're running in the daemon mode, if you want to see the logs, you can do docker logs and the name of the container or the ID, and it'll show you the logs from the container. You can also do a continuous logs and see running logs. You can follow the logs with the -f command. So now if I go here and refresh it, it'll going to give us more information here. If your application gets stuck for some reason, you could do a Control C and restart the app. In the list of containers, you'll see that the last restart or uptime of this container is just 5 seconds because we have just restarted it. We can see the process inside the app container or any container you want, and the command will show you the top process running inside. You can also kill the app So that will remove the container from the host machine. And I exited from, so the container has been stopped. It's not removed from the machine yet. So you'll have to use delete to get rid of it completely. Although the containers do not persist information, but that's only when they are deleted. Till the time a container is available here, if I restart it, it's going to give me the same persistence as any other virtual machine or a server. Let's go to lab 106. This is one is for the networks. So if I go into this and do list the network which are available for the Docker, you'll see that default, you'll see bridge, host, and none. Let's create a new network with the property of bridge. Now, if you list it again, you'll see that new network has been created. It has the name MBN and the bridge is the type or the driver used. We can have our container use a specific network. So in this case, I'm saying run a container in the daemon mode with the port 8080 for the host and 80 for the container, name it web, and use the network MBN with the image Nginx. We can inspect our container and make sure that indeed it is using the network which you're talking about. So if you scroll it up, inspect will give you complete information regarding that container. So it'll tell you the image being used, what is the entry point, and in the network settings, you'll see what port is the host port and what is the container port. And it tells you here which network has been used. You also use a formatting or a filter to get a specific information from inspect. And here we're saying in the format, give us the range of network settings, network and IP address, which shows us the IP address in this particular, for this particular container. Let's run another container with the name jump host and use the Alpine image. We're inside the container. Now, if we try to do a wget to our other container, which is 172.19.02, you'll see that it probably will gonna fail because that container is in its own network. In order for them to be able to communicate, they have to be in the same network. So if I use the command connect mbn, that's a network name and the name of the container. Now these containers are in the same network. Let's do docker start. And let's go back to the exec. Go back inside the shell. run the command, and you see that you got the output. If you do cat index, that is the Nginx page. You can also inspect the network, and they'll give you the complete information about what all containers are part of it. Here we have jump host and web. If you want particular container to be removed from the um, network, you can use Docker network disconnect MBN and name of the container. Now, if you're going to inspect the MBN, you're going to see there's only one container left, which is the web. You can remove that one as well. And another inspect will show that there's no more container in this network now. In order to remove the network, you have to use Docker network rm command, and your network will be removed. So if I do Docker network ls, you'll see that there are only 3 default network and our MBN network has been removed. So Docker info give you all the configuration setting for the Docker tool on that server, and you can grep it with the network to see the network settings. The type of network allowed in this environment are bridge, host, IPVLAN, MAC VLAN, null, and overlay. Those are the drivers, and we can go into details on them in future labs. So Docker network will gonna give you the information or the help for all the related commands for the network. So this was the goal for us for the today's workshop. Anything you have questions? Yeah, these labs are freely available for everyone and anybody can access these labs. Again, our website is sharelearn.com and we invite you to join our Facebook and LinkedIn group and Slack and Telegram channels as well. Feel free to ask any questions you might have related to Docker or DevOps or Kubernetes in any of the channel. So we're gonna have a Kubernetes session tomorrow. If you guys want to join, feel free. It'll be the same format. We're gonna have a YouTube live video for it, and there will be a Google Meet where you can join and interact with us if you want to ask a question or want to share your screen with any of the issues which you're facing with these labs. Feel free to do that. So Docker is the tool which run the containers and manages it helps you build a container image is just the information regarding the container, and then it's like an operating system, and then container is like a virtual machine. So as the virtual machine uses the operating system to run itself, the same way container uses image to run itself. And Kubernetes is an orchestration tool. So with Docker, you have to start individual container, make sure it is running. And if it is down, you have to bring it up or restart it. But with the Kubernetes, Kubernetes will have its own mechanism to do health check and allocate. In a Kubernetes, you get a cluster of servers, and Kubernetes will automatically allocate a server for your container. Sure, we'll have much more discussion. We can discuss Kubernetes in details in tomorrow's workshop, or check our previous workshop, which has a lot of information. It's available on our website, ShareLearn.com. Yeah, we're gonna have next. We're working on more advanced labs on our website. So hopefully, with the next workshop, we're gonna have more labs, and we'll go through advanced labs for Docker. And on the next day, we're gonna have a Kubernetes workshop. Okay, so make sure to subscribe to the channel and like the video. If there are no further questions, I would say thanks for your time, guys. All the labs are freely available for you. We're gonna put the next workshop information on our website soon, and we're gonna reconnect with you. Join us on the Facebook group, join us on the LinkedIn group, and Slack and Telegram channel. Tell us what you would like to learn next, and we'll be happy to help you. Thank you for your time, and have a good one.